Welcome back, everyone. Today, we're diving deep into the world of AI.
Oh, exciting.
Yeah. Specifically, how researchers are pushing the limits of AI decision-making, in really complex situations.
Yeah,
And we're focusing on this paper, Generative World Explorer.
I am excited to break this down with you. Yeah, this research is really fascinating in its approach to some of the limitations we see in current AI systems.
All right, so let's set the stage here.
Okay.
We often hear about, AI getting better and better at decisions, but what are some of the big challenges that are still out there?
Yeah, so a lot of AI systems rely on what we call world models.
Okay.
And that's essentially a way for the AI to kind of represent and predict what's going to happen next in its environment. But these models really struggle when they only have partial information available.
Oh, okay.
Like imagine driving through a really busy intersection, but you've got blinders on.
Oh, scary.
Yeah, and that's what Generative World Explorer, or Genex, as the paper calls it, tackles.
Okay, so Genex helps AI deal with limited information then.
Right.
How does it do that? The paper mentions the AI using its imagination.
Yeah, so in section 3.1, which is titled Generative World Exploration, they describe Genex as a video generation model.
Okay.
So it lets the AI simulate exploration within its environment, but not in the real world.
Yeah.
Instead, it's happening virtually, in the AI's kind of mind's eye.
Interesting.
And this lets the AI generate imagined observations and fill in those gaps in its knowledge.
So instead of just reacting to what it can see, it's kind of generating potential scenarios to better understand everything around it.
Exactly, yeah. And the researchers give a really striking example in Figure 1.
Okay.
So picture this. An autonomous car, which they call Agent 1, is approaching an intersection.
Okay.
It sees a taxi, or Agent 2, suddenly braking.
Uh-oh.
But Agent 1 can't see why.
Right.
So Genex allows the car to virtually see from the taxi's perspective,
Oh.
revealing that an ambulance is coming through.
Oh.
So now that imagined observation explains why the taxi stopped and helps the car avoid a potential accident.
So it's almost like giving the AI the ability to anticipate what could happen by imagining those different possibilities.
That's a great way to put it. And this imagination isn't just for reacting to these immediate situations.
Okay.
Section 3.2 highlights how Genex can actually be used in two ways.
Okay.
First, there's goal-agnostic exploration, where the AI explores freely to build a richer understanding of its environment, and they show that in Figure 2b.
Gotcha.
Then second, there's goal-driven exploration, which is shown in Figure 2c, and this lets the AI use instructions, say from a language model like GPT, to move towards a specific goal.
So it can kind of explore out of curiosity, or it can follow instructions to achieve a specific objective.
Right, exactly.
That's pretty versatile.
Yeah.
But let's get a little bit deeper into how it actually works.
Okay.
The paper mentions using panoramic images, which makes sense if the AI wants a full view, but there's also this spherical consistent learning. What's that about?
Yeah, so it's all about making those imagined videos as realistic and as coherent as possible.
Okay.
Think of it like this. You're exploring a virtual world, and as you turn your head, you want the environment to flow smoothly, right?
Right.
Spherical consistent learning, which is described in Section 4, ensures that the generated videos maintain visual consistency as the AI explores its imagined space.
Makes sense. It's creating a seamless experience so it doesn't get confused by sudden jumps or anything.
Exactly.
Now, the paper also compares Genex to a 6-view navigator baseline in Figure 18.
Yeah.
Why is that comparison important?
So the 6-view navigator uses 6 separate diffusion models, each representing a face of a cube, to build its world model.
Right.
But that approach leads to inconsistencies at the edges where those views meet.
Right.
So Genex's panoramic approach, with that spherical consistent learning, results in a much smoother and more believable virtual world for the AI.
So it's like having a high-resolution panorama versus a bunch of photos stitched together.
Yeah.
The panorama gives you a much more complete and accurate picture.
Precisely, and that leads to something they call imagination-driven belief revision in Section 4.1.
Okay.
So as the AI explores, even virtually, it updates its beliefs about the world based on what it's seeing.
Oh, interesting.
Right, and this constant revision helps it make better decisions because its understanding of the situation is always being refined.
Okay, so it's not just seeing things. It's about integrating those imagined experiences into the AI's existing knowledge.
Exactly.
Fascinating. And I understand Genex isn't limited to just single agents.
Right.
It can also be applied to multi-agent scenarios.
Absolutely, yeah. One of the most impressive aspects of Genex is its ability to actually facilitate collaboration between multiple AI agents.
Ah.
So Section 4.2 talks about how Genex lets one agent virtually step into the shoes of another agent and imagine their perspective.
So it's not just about one AI understanding its surroundings.
Right.
It's about multiple AIs understanding each other as well.
Yeah.
That sounds incredibly complex.
It is.
How do they even test something like that?
So they created two specialized data sets.
Okay.
The first is Genex-DB, detailed in Section 5.1, and it's a synthetic urban scene data set with these different visual styles: realistic, animated, low texture, and geometric. And that's all shown in Figure 6.
Okay.
The second data set is called Genex-EQA, and this one is designed to test embodied decision-making in both single and multi-agent scenarios, also explained in Section 5.1.
So Genex-DB is like the training ground,
Yeah.
and Genex-EQA is the test track to see how well it does in different situations.
Exactly.
What kind of situations are we talking about?
They designed a range of scenarios, some with just a single agent and some with multiple agents interacting to evaluate Genex. And Figure 5b shows a really compelling example.
Okay.
Imagine an agent at a red light waiting to go straight.
Okay.
The light turns green, but there's a speeding car coming from the right that wants to turn.
Oh,
At the same time, there's a pedestrian crossing the street right in front of the waiting agent.
that sounds like a recipe for disaster.
It is. If the agent only relies on its limited view, it might drive forward and cause an accident.
Right.
But with Genex, the agent can imagine the perspectives of both the speeding car and the pedestrian.
So it can understand that the speeding car might not see the pedestrian and that the pedestrian might not see the car.
Exactly.
It's like giving it a sense of social awareness almost.
Yeah, with this information from its imagined exploration, the agent chooses to wait,
Oh, wow.
preventing a potential collision.
Wow.
And this really highlights how Genex enhances decision-making, especially in complex multi-agent situations.
Incredible. It's like Genex is giving the AI this deeper understanding of the world, not just visually, but contextually.
Right.
But how do the researchers know if this imagined exploration is actually leading to better decisions?
So to evaluate Genex's performance, they used various metrics that are described in Section 5.2, like freshet video distance, or FVD, structural similarity, or SSIM,
Okay.
and learned perceptual image patch similarity, or LPIPS. They also assessed the quality of the AI's exploration using what they called imaginative exploration cycle consistency, or IECC, and that's explained in Section 5.3.
So they're checking if the AI's imagined world stays consistent.
Right.
And if the videos that it generates are high quality,
Exactly.
what were the results?
So the results, which are shown in Table 1, showed that Genex consistently beat the 6View Navigator baseline in terms of the video generation quality.
Yep.
More importantly, as highlighted in Table 2, Genex generalized well to real-world scenarios.
Oh, wow.
Even though it was trained on synthetic data, it did remarkably well on Google Street View images.
So even though it learned in a virtual world, it could still understand and navigate in real-world scenes.
Exactly.
That's a pretty big finding.
It is.
Did they uncover anything else about what Genex can do?
They did. So while the initial focus was on 2D environments, the researchers, as discussed in Section 5.3, found that Genex actually showed surprising 3D capabilities. Yeah, they were able to combine Genex with other tools to create these 3D reconstructions of the world, and those are shown in Figures 20 and 21.
Wow, so Genex is not just about imagining in 2D. It can actually help AI understand the world in 3 dimensions.
Right.
That's a whole other level of perception.
Exactly. This unexpected finding hints at even broader applications for Genex, going beyond navigation and decision-making.
This is all so fascinating. I'm really starting to understand why this paper is getting so much attention in the AI world.
Yeah.
But before we go any further, let's look closer at the technical details in the appendix.
Okay.
I know there's a lot more to unpack there.
You're right. The appendix is packed with additional insights that really showcase the depth of this research.
All right, then, let's dive into the appendix and see what other treasures we can find about Genex.
Sounds good. So let's start with Appendix A by 1,
Okay.
which really dives into the specifics of those panoramic images we talked about. They're super important for Genex's ability to create this seamless and immersive virtual world for the AI.
All right, the paper mentions something called equirectangular panorama images.
Yeah.
Well, what are those exactly?
Well, they're basically a way to represent a full 360-degree view in just a 2D image.
Okay.
It's like capturing everything around you in a single shot.
Okay.
Appendix A Pot 1.1 actually describes the mathematical framework they use to define these images.
Okay.
They introduce two coordinate systems, the spherical polar coordinate system, which they denote as S, and then the Cartesian coordinate system for the panoramic images, denoted as P.
So they have a way to mathematically translate between the 3D space the AI is exploring
Right.
and the 2D representation in that panoramic image.
Exactly. And equations 6 and 7 in this section actually lay out the transformations between those coordinate systems.
Okay.
So this ensures that every point on the sphere representing the AI's view is accurately represented on that 2D image.
Gotcha. That's pretty intricate.
It is.
What's the benefit of using this specific type of panoramic image?
Well, the cool thing about these equirectangular panorama images is that they allow for these seamless transformations, particularly rotations, as explained in Appendix A.1.2.
Okay.
The AI can essentially look in any direction without losing information or creating distortions in the image.
Oh, that's cool.
Yeah, and equations 8 and 9 actually describe the mathematical transformations for rotating these images.
So the AI can explore its imagined world smoothly and naturally, just like we do in the real world.
Exactly. They also discuss how they break down these panorama images into cube maps, and that's shown in Figure 11. This involves converting that 360-degree view into 6 separate images, each one representing a face of a cube.
Gotcha.
And this representation is especially useful when working with multimodal LM agents, which we'll get to a little bit later.
Okay, cool. Let's move on to the training process itself then.
Okay.
I imagine the appendix has some details about how they taught Genex to generate these incredibly realistic and consistent videos.
It does. Appendix 8.2 is packed with information about that training process. Table 5 actually gives a full list of the hyperparameters they used for training the Genex diffuser.
Okay.
It includes things like the learning rate, image dimensions, training frame count, and more. It's like the recipe card for creating a powerful Genex model.
So they're fine-tuning the model to get the best results.
Right, and it's not just about fine-tuning the algorithm.
Okay.
Table 6 in this section highlights the computational resources they used for training Genex. And they needed a lot of computing power, 384 A100 GPU hours to be exact, to get those impressive results.
Wow, that's a testament to how complex this research is.
Yeah.
They're really pushing the boundaries of what's possible with AI, which requires some serious computing power.
It does.
Let's talk more about that Genex-DB dataset.
Okay.
You mentioned it includes a variety of visual styles. Can you elaborate on why that's so important?
Well, the researchers wanted to make sure that Genex could generalize well to different types of environments, not just ones that look photorealistic. So they made Genex-DB with those 4 distinct visual styles:
Right.
realistic, animated, low texture, and geometric.
Gotcha.
They wanted to see if Genex could learn the basic principles of navigation and exploration, regardless of what the world looked like visually.
So it's like saying if you can navigate a city made of Lego blocks, you should also be able to navigate a city made of photorealistic skyscrapers.
Exactly, yeah. It's about testing its ability to adapt and learn in different contexts.
How did they actually create these diverse data sets, though?
They used a bunch of powerful tools to build these virtual worlds.
Okay.
They used Unreal Engine 5 for the realistic city,
Okay.
Unity for the low texture and animated cities,
Gotcha.
and Blender for the geometry city.
Okay.
So basically, they simulated driving through these virtual environments, capturing video frames along the way.
That's quite an undertaking. How big are these data sets?
Table 7 in Appendix A.3 gives some insights into the scale of Genex-DB. It's got over 40,000 scenes, 2 million frames, and it covers a huge 400,000 meters of traversal distance.
Wow.
They really went all out to create a rich and diverse training environment for Genex.
Now let's talk about the Genex-EQA data set.
Okay.
This one's specifically for testing the AI's decision-making abilities, right?
Yeah.
How does it differ from Genex-DB?
So while Genex-DB is focused on training Genex's generative capabilities, Genex-EQA is all about how well Genex improves embodied decision-making. It has over 200 carefully designed scenarios, categorized into single-agent and multi-agent scenarios, which is illustrated in Figure 13.
Can you give some examples of these scenarios?
Sure, they include real-world inspired situations like navigating intersections with other cars, responding to pedestrians crossing the street, even reacting to emergency vehicles. And they designed specific control sets to really isolate the impact of Genex on decision-making.
So they're systematically testing how Genex influences the AI's choices in all these different situations.
Right. For example, they might have one scenario where an ambulance is approaching
Hmm.
and another where it's driving away.
Okay.
This allows them to see exactly how Genex is affecting the AI's actions.
All right, so they've created these elaborate scenarios,
Yeah.
but how do they actually measure the AI's performance?
Mm-hmm.
I know they mentioned using both machine and human evaluations.
Right. Appendix B goes into detail about how they evaluate everything.
Okay.
On the machine side of things, they use metrics like decision accuracy,
Okay.
gold action confidence,
Mm.
and chain of thoughts accuracy, and all of that's described in Appendix B.0.4.
Gotcha.
These metrics give quantitative measures of how well the AI makes decisions and how logically sound its reasoning is.
So they're looking at both the outcome of its actions
Right.
and the thought process behind those actions.
Exactly. And to make things even more interesting, they even used GPT-4o as a judge to evaluate the AI's chain of thought.
Wow.
Figure 17 shows the prompt they used for this LLM as a judge evaluation.
That's fascinating. They're bringing in another powerful AI to assess the decision-making of the Genex AI.
It is.
What about the human evaluations then?
Mm-hmm.
How do they factor human judgment into all of this?
They design a really rigorous three-step process outlined in Appendix B.0.3 to ensure fairness and prevent information leakage.
Okay.
First, the evaluators were only given a text description of the scene.
Gotcha.
Then, they were shown the egocentric view, which is the AI's initial perspective.
Mm-hmm.
Finally, they were shown the pre-navigated Genex generations,
Okay.
allowing them to see how the AI imagined the situation.
So they're gradually revealing information to the human evaluators
Right.
to make sure they can assess the AI's decision-making process objectively.
Exactly. And this careful approach helps capture the subtleties that machines might miss, providing a more complete picture of Genex's impact.
Now, let's go back to those 3D capabilities you mentioned earlier.
Okay.
The paper highlighted how Genex was used with other tools to create 3D models of the world. Can you explain how they did that?
So this part of the research, which is detailed in Appendix B3, highlights Genex's potential beyond 2D navigation.
Okay.
To make the egocentric 3D reconstruction, as shown in Figure 20, they used Depth Anything V2.
Okay.
This is a really powerful tool for monocular depth estimation.
Gotcha.
This tool lets them estimate the depth of each pixel in that panorama image,
Okay.
basically turning it into a 3D point cloud.
So they're adding a depth dimension to the AI's imagined world.
Exactly, and the results are pretty amazing.
Wow.
You can actually virtually fly through this 3D point cloud and experience the scene from the AI's point of view.
That's incredible. But what about creating a 3D model of the entire environment, not just from the AI's perspective?
Yeah.
Did they do that too?
They did. To create what they call the exocentric 3D reconstruction, they used a sophisticated 3D reconstruction tool called DUST3R.
Okay.
By using Genex to make multiple panorama images from different points of view.
Yeah.
Simulating the AI exploring the environment, they were able to feed all that data into DUST3R
Gotcha.
and create really detailed 3D models of the entire environment.
Wow.
And Figure 21 shows off some of these impressive reconstructions.
It's amazing how they combine Genex with these other tools to do even more.
Yeah.
It really shows how versatile and powerful this technology is.
I agree. It's like Genex isn't just about imagining the world. It's about understanding it in a much deeper, multidimensional way.
And the appendix doesn't stop there.
No, it doesn't.
There's tons of information about specific training details, evaluation metrics, even the challenges they ran into.
Right.
Let's dive into those details a little bit more.
Okay.
I'm curious about the specific models they trained for those different visual styles in Genex-DB, as well as what they learned from those experiments.
Okay, so Appendix B2 gives a detailed breakdown of the different Genex models they trained for each visual style in Genex-DB.
Okay.
Interestingly, they also evaluated how well the models could generalize across styles. Oh, interesting.
For instance, they tested if a model trained on the realistic city could generate believable scenes in the animated city.
So they're basically seeing if the AI can transfer its knowledge from one visual domain to another.
Exactly. And they found that Genex showed promising cross-scene generalization capabilities.
Okay.
This means that a model trained on one style could, to a decent extent, generate coherent scenes in a completely different style.
Wow, that's impressive.
Yeah.
It suggests that Genex is learning something fundamental about navigation and exploration that goes beyond how things look.
Right.
It's not just memorizing scenes, it's developing a deeper understanding of spatial relationships and environmental dynamics.
Exactly. And this understanding is further shown by all the different evaluation metrics they used.
Right. Appendix B is full of details about those metrics, which
Yeah.
go beyond just judging the quality of the videos.
Right.
I know they use metrics like Frische video distance, FVD, learned perceptual image patch similarity, LPIPS.
Peak signal-to-noise ratio, PSNR,
Right.
and structural similarity, SSIM, to assess the quality of the videos.
Yeah.
But they also mentioned cycle consistency. What's that about?
So cycle consistency basically measures how well the AI's imagined world stays coherent and consistent as it explores.
Okay.
They wanted to make sure the AI didn't get confused or lost in its own imagination.
Gotcha.
Appendix B1 explains this metric in detail and how they calculated it.
So it's not just about making visually appealing video.
Right.
It's about making a believable and logically sound virtual world for the AI to explore.
Exactly. And to capture those finer details that numbers alone can't fully represent, they also did those human evaluations we talked about before. They wanted to get a sense of how believable and immersive the Genex-generated experiences were from a human perspective.
Makes sense. It's acknowledging that AI isn't just about numbers.
Yeah.
It's also about creating experiences that resonate with humans.
Right.
Let's talk more about those LLM agents they used. I'm curious about how they guided those agents to make decisions using Genex.
So that's where things get really interesting. They used a combo of clever prompt design and iterative feedback to guide the LLM agents, as explained in Appendix B0.1.
Okay.
Basically, they gave the LLM instructions and asked it to analyze the scene, find potential obstacles, plan a path, and decide what action to take.
So it's like giving the LLM rules and a virtual joystick to explore the Genex world.
Yeah, that's a good way to visualize it. And they tested different levels of access to Genex for the LLM agents.
Like,
Sometimes the LLMs had direct access to the imagined videos. Other times they only got text descriptions of what the AI was seeing.
oh, interesting.
This let them see how different levels of imagination awareness affected the agent's decisions.
Did they find any major differences in performance based on how much access to Genex they had?
Yeah, they did. In a lot of scenarios, the LLM agents did better when they could actually see the imagined videos.
Oh, wow.
It was as if seeing the world through the AI's eyes, instead of just reading about it, helped them make better decisions.
It makes you wonder if there's something special about the visual nature of imagination
Yeah,
that helps with problem solving and decision making, even for AI.
right.
But what about those multi-agent scenarios?
hmm
How did they get the LLM agents to work together using Genex?
So for that, they came up with this idea called imagined belief sharing,
Okay,
which they explain in Appendix B0.2.
gotcha.
Essentially, they let one agent virtually step into another agent's shoes
Oh, wow.
and see the world from their point of view.
That's cool.
This shared imagination helped the agents understand what each other might do and make more coordinated decisions.
So it's not just about each AI understanding its own surroundings. It's about them building a shared understanding of the situation,
Yeah.
almost like a collective imagination.
That's a good way to put it. And they use the power of large language models to make this belief sharing happen. Appendix B.2 breaks down the prompts they use to guide the agents in these multi-agent situations.
Gotcha.
They basically got the agents to think out loud about what the other agents might be seeing, thinking, and planning.
Interesting.
This inner dialogue helped them sync up their beliefs and make more collaborative decisions.
This is groundbreaking stuff.
It is.
They're not just making AI that can see and act. They're making AI that can empathize and work with other AI.
Right.
It's like a preview of a future where AI systems can work together seamlessly, just like humans.
It really is. It opens up amazing possibilities for AI systems that can tackle those tough problems that need coordination and cooperation,
Yeah.
like disaster response, traffic management, even scientific discoveries.
But with any powerful technology, it's important to talk about the challenges and limitations.
Yeah.
The appendix must talk about some of those too, right?
You're right. Even with all the incredible advancements in this paper, the researchers are honest about the challenges and areas for future research. One of the main things is the reliance on synthetic data sets.
Okay.
While Genex has done well generalizing to real-world data, it's really important to test and validate it in more diverse and complex real-world environments.
That makes sense. The real world is full of surprises and unexpected things
It is.
that even the best simulations can't fully capture.
Exactly. Another challenge is how computationally complex it is to train and run Genex.
Okay.
It needs a ton of computational resources, which can make it hard for everyone to use.
Right.
Not everyone has hundreds of A100 GPUs just lying around.
So while Genex has huge potential,
Yeah.
There are still practical things to figure out before it can be used everywhere in the real world.
That's true, however. These challenges also show exciting opportunities for future research and development.
Hmm.
As algorithms get more efficient and hardware gets more powerful,
Right.
we'll probably see Genex and similar technologies becoming more accessible and impactful.
This has been a really insightful look at the technical side of Genex. The appendix has shown us so much about how it works, how it's trained, and how it's evaluated.
Right.
But what's most fascinating to me is what it tells us about the potential of AI imagination.
Yeah,
It's like we're seeing the beginning of a new type of intelligence,
it is.
one that can not only see and act, but also imagine and reason in ways we thought only humans could.
I completely agree. This research is a powerful reminder of how much AI can change things. And it's not just about making smarter machines.
There you go.
It's about understanding what intelligence really is
Yep.
and the endless possibilities of human ingenuity.
Well said. Now, before we wrap up this episode,
Okay.
I want to point out one more interesting detail from the appendix.
Okay.
It really gets at the core of Genex and how it could change the world.
What is it?
In Appendix B1, they talk about a baseline model that they compare Genex to. They call it the 6-view navigator.
Okay.
This model basically takes the 360-degree panoramic view and splits it into 6 separate images, each one showing a different direction.
Gotcha.
It's like looking at the world through 6 windows instead of seeing the whole picture at once.
I see where you're going with this.
Yeah.
The 6-view navigator represents a more limited and fragmented view of the world.
Exactly.
It's like a reminder that without imagination and the ability to create a whole mental model, our understanding of the world is incomplete.
Exactly. Genex, with its ability to generate these seamless and immersive imagined experiences, helps AI break free from those limits.
Right.
It's like opening a door to a whole new world of understanding.
It's a great analogy, and it speaks to how powerful imagination can be. It's not just about escaping reality.
Yeah.
It's about broadening our horizons,
Right.
exploring possibilities, and ultimately understanding the world and ourselves better.
Well said. And on that note, let's wrap up this episode of The Deep Dive.
Yeah, it really is a fascinating example of how AI is going beyond just, recognizing patterns and moving towards a deeper understanding of how the world works.
Yeah. And speaking of deeper understanding,
Okay.
I want to touch on those large language models, or LLMs, that were used as agents in some of those Genex experiments.
Right.
The appendix goes into detail about how they incorporated LLMs into this research.
It does, yeah. Appendix B, 1.1, gives a close look at the prompts they use for world exploration with those LLM agents.
Okay.
They basically guided the LLMs to interact with the Genex environments using instructions.
Gotcha.
The LLM had to analyze the scene, identify potential obstacles, plan a route, and then decide what actions to take.
So they're not just giving the LLM raw visual data.
Right.
They're giving it a structured way to understand and interact with the world Genex created.
Exactly. It's about using the LLM's ability to understand and generate language to guide its actions in that virtual space.
Okay.
And what's interesting is they tested different levels of access to Genex for those LLM agents.
Oh, okay.
Sometimes the LLM could directly see the imagined videos made by Genex, but other times it only got text descriptions of what the AI was seeing.
So they were testing if seeing the imagined world directly
Right.
versus just getting a description
Yes.
impacted the LLM's decision-making.
Exactly.
Did they find any big differences?
They did. In a lot of cases, the LLM agents performed better when they had that direct access to the videos.
Interesting.
It seemed like even though the visual information was imagined,
Right.
it gave a richer context for making decisions compared to just text descriptions.
It makes you think that there's something about the visual nature of imagination that's really powerful for problem solving and decision making, even for AI.
Right.
But what about those multi-agent scenarios then?
Yeah.
Where you've got multiple LLMs that have to work together.
Right. So that's where imagined belief sharing comes in.
Okay.
And they describe that in detail in Appendix B 0.2.
Gotcha.
Basically, they let one LLM agent see the world from another LLM agent's perspective,
Wow.
using Genex to generate those shared points of view.
That's really cool.
Yeah, and this helped the agents understand each other's views and what they might do,
Okay.
leading to better coordination and collaboration.
So it's not just each AI understanding its own surroundings. It's
Yeah.
about developing a shared understanding,
Yeah.
like a collective imagination, almost.
That's a great way to put it, and the results from those multi-agent experiments were impressive.
Oh, wow.
They found that the LLMs could effectively collaborate in a bunch of challenging scenarios,
Okay.
showing just how much potential Genex has to make complex AI teamwork possible.
That's incredible. I'm also curious about the challenges they faced during this research.
Mm-hmm.
The appendix must talk about some of the hurdles they had to overcome.
Right. Appendix B does give some insights into the challenges they ran into.
Okay.
One big one was training Genex to generate high-quality and consistent videos.
Okay.
They had to deal with things like blurry frames, inconsistent lighting, and objects popping in and out of existence.
So even though the results are amazing,
Yeah.
it wasn't always easy.
No, it wasn't.
There were technical obstacles they had to work through to make Genex really work.
Exactly. It's a reminder that even with the most advanced AI,
Mm-hmm.
there are still complexities and challenges to figure out.
Yeah.
It really highlights the importance of careful experimentation and constant refinement
Right.
to achieve those breakthroughs.
This deep dive into Generative World Explorer has been really eye-opening.
It has.
We've gone over the main ideas, dug into the technical stuff,
Mm-hmm.
and even found some surprising things this tech can do.
Yeah,
It's been a fascinating look at how AI is evolving.
it has.
And Generative World Explorer gives us a glimpse into a future where AI imagination could be the key to solving problems and even working together better.
I couldn't agree more. And as we wrap up,
Oh, yeah.
I encourage everyone listening to check out the full paper. The link will be in the show notes.
Great.
Take a look at the figures, dig deeper into the details,
Mhm.
and most importantly, keep thinking.
Yeah.
How could Genex be used in your field? How might this change the world in the years to come?
This has been an awesome deep dive.
It has.
Thanks for joining us. And until next time, keep exploring and keep imagining the possibilities.